Hi, this is Algebra 1, Lesson 74. We're going to talk about scientific notation, and we're starting on page 301. In science courses, it's sometimes necessary to use extremely large or extremely small numbers. For example, to calculate the number of molecules in 1,000 liters of gas, it would be necessary to multiply 1,000 times 1,000 times this really large number, which represents the number of molecules in a cubic centimeter of gas. Instead of writing all those zeros and getting lost in the middle of them and probably making a mistake, we can write numbers like this in scientific notation. When we use scientific notation, we multiply the number by the power of 10 that will place the decimal point immediately to the right of the first non-zero digit in the number. For example, we have 0.0000416. Okay, we want the decimal to be at the right of the 4. So if we put this over 1 and we multiply it, we want the 0 to move over 1, 2, 3, 4, 5. The decimal to move over 1, 2, 3, 4, 5 places. So we're going to multiply it times 10 to the 5th over 10 to the 5th. And this is going to equal, this times this equals 4.16. It's still over 10 to the 5th. But we can rewrite 10 to the 5th in the denominator as 4.16 times 10 to the negative 5. And if we leave it in that form, that is the scientific notation for this number. There's an easier way to do this. When we look at numbers in scientific notation, such as 4.16 times 10 to the positive b, or 4.16 times 10 to the negative b, we're going to think of this, the 10 to the positive b, or the 10 to the negative b, as a decimal point indicator. So this 10 to the positive b tells us that the true location of this decimal is b places to the right of where it is written right now. Okay? If it's a negative b, it's telling us that this decimal in reality is b places to the left of where it is right now. So for example, if we're looking at 4.165 times 10 to the negative 7, the negative is telling us that the decimal is actually 7 places to the left. So that would be 4165, and the decimal is going to go from here to the left 7 places. 1, 2, 3, 4, 5, 6, 7. So here's where the decimal is, and we're going to fill in all of these loops with zeros. Okay? So this number is actually this number. This negative 7 is telling us that the actual position of this decimal is 7 places to the left. Okay? Let's look at this number. 4165 times 10 to the positive 7. So this decimal place indicator is telling us that the true location of this decimal is 7 points to the right, 7 places to the right. So we do 4165, and the decimal is going to move to the right. 1, 2, 3, 4, 5, 6, 7. And there's the decimal. And so this number is 41,650,000. So this equals this. Okay? So here's our first example. Let's write 714,600,000 in scientific notation. Okay, we want the decimal to go between the first two non-zero digits. So in this case, it will be 7.146. The actual place of the decimal is 1, 2, 3, 4, 5, 6, 7, 8 places to the right. Okay, so we've got 7.146, and the actual position of this decimal is 8 places to the right. So times 10 to the 8th. Let's try some more. Write 0.000316 in scientific notation. Okay, we want the decimal to go between the first two non-zero digits, so it'll be 3.16, and that means we're moving the decimal 1, 2, 3, 4 places, and the true place of the decimal is to the left, so this is going to be -4. Okay, we moved it 4 places. The true spot is 4 places to the left. Okay, here's a more complicated one. Write 0.000316 times 10 to the -7 in scientific notation. This is scientific notation, obviously, but the form is incorrect. For the form to be correct, we need the decimal to be between the first two non-zero digits. So we need the decimal to be over here. Usually when you end up with a problem like this, you've been dealing with large numbers and you multiplied one scientific numeral times another one, and it moves the decimal around in crazy places, so now you have to put it back into standard form. Okay? So we want the decimal to be between the first two non-zero digits, so it's going to be 3.16. That's moving it 1, 2, 3, 4 places. So this would be 3.16 times 10 to the -4. That's what we just did. But it was already times 10 to the -7. And you know that when you have the same base and they're multiplied to each other and they have different exponents, you add the exponents, right? -4 plus -7 is -11. So the correct answer is going to be 3.16 times 10 to the -11. Okay, here's one that went the other way. We've got write 0.000316 times 10 to the 7th in scientific notation. So once again, we have 3.16. We've moved the decimal 1, 2, 3, 4 places. And it was over to the left, so we're going to write -4, but we still have a times 10 to the 7th to deal with. -4 plus 7 is 3. So we have 3.16 times 10 to the 3. Okay, that's it for this lesson. Try the practice problems. Do all the problems from this lesson. Let me know if you have any questions. Thank you.